about anatomic scanning using the Structure Sensor 3 and the Structure SDK. I am the CTO of Structure. Back in 2014, we launched the Structure Sensor, the original STO1 sensor. It was originally aimed at hobbyists and developers, but it really unlocked a revolution in healthcare by, for the first time, making it affordable, easy to scan patients. In 2019 and 2021, we launched the Structure Sensor Mark II and the Pro, which drove us to a smaller sensor, lighter weight. Increased resolution. Now, about 1 year ago, we launched the Structure Sensor 3, which uses the same baseline distance as the original sensors. New wavelength range at 940, which, for example, is scanning a foot, which is still today the main application of that sensor, 80% of our users today. But I also showed that I can easily do a body size scan. So compared to its predecessor, the Structure Sensor 3 operates at 940, making it more robust and less sensitive to sunlight. It also has a much larger battery. It also became a lot stiffer, more robust. We learned the calibration is improved and it's kept longer. It has a much more powerful processor, more memory, so it can process more information faster, and that means that it can withstand water from multiple angles. Also, it's more robust to drop tests, as we have a proven track record assisting our customers obtain medical regulatory approval. One from Gauss Surgical. They were the first actually to obtain FDA Class II device approval for measuring a blood loss during operations. Decimal, it's a company that they have FDA approval as a Class II device to replace MRI scans to create targets for radiotherapy. Okay. eCare, they use our product for 3D wound documentation. Corify Care in Spain, they use our product to do non-invasive cardiac mapping. Skia, they have 2 approvals for face and body scanning. So we rely on having 2 IR cameras, left and right, and we have a projected pattern. So here's a real-life example. So in this case, I'm scanning a pipe, which corresponds to a human limb, maybe an arm or a small leg. And do that with a 0.27 millimeter bias and 1.4 millimeter RMSE. Yeah. For an object of that size, it corresponds to a fractional error of 0.29%, so quite small. So we have a long history of adoption of this SDK. It was first available in 2014. Today, we count on more than 400 apps available using that SDK. We count with more than 4 million scans per year, most of those patient scans. It enables our customers to use multiple sensors, including Apple TrueDepth and LiDAR sensors. We have 2 ways to access meshes. We have our legacy method, continuous mesh access. The continuous mesh access is especially important when you're doing AR, VR applications. The new method, mesh extract, first available SDK 3.5. It enables the user to visualize the mesh before being able to say, I like this mesh, I'd like to extract it. So, okay, then why do you need continuous mesh access? I'm showing here an example from one of our partners, Skia. What they're doing here is that they are combining a patient DICOM data, MRI, CAT scans, and they are showing that they scan the patient, and then they show that in continuous time as they continue to track the patient. So it shows the ability to visualize patient internal organs, internal data, while the patient is waiting for a procedure every day. They're about to obtain approval for FDA approval for procedures in the US as well. Okay. We have now quarterly updates of the Structure SDK, so at least once a quarter we can count on having a new version of the SDK released with improvements. More anthropometric features are going to come up soon, starting with face anthropometrics.